Good morning, friends and dear students. It gives me immense pleasure to be here for my course, Aircraft Systems. Today I am in Definition and Terminology, Module 4. This Module 4 of Aircraft Systems belongs to Engine Control and Fuel Systems. I am Dr. Dwivedhi, Professor from Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad, India. As of now, I have done all the 5 modules. The first module consists of Introduction to Aircraft Systems. Second module consists of Electrical System and Environmental Control System. Third module consists of Hydraulic and Pneumatic System. Fourth module consists of Engine Control and the Fuel System. Fifth module consists of Flight Control and Flight Control Systems. So, the topics of my aircraft systems as per the module I have already covered. Some problem solving and some case studies. Nearly 15 I have already completed. Now I am in my module 4, definition and the terminology. In this, some important terms which are used in aircraft systems course I am going to discuss and hope this will be quite good and quite useful. You know that first off, just I will show you here. This is the aircraft. In this aircraft, this is the fuselage, this is the main wing, this is the horizontal tail, this is the vertical tail. All controls, the flight controls are, ailerons are on the wing trailing edge at the tip. Your elevators are at the trailing edge of horizontal tail. Rudders are at the trailing edge of the vertical fin. And this is here engine. So I am focusing on how this engine power is controlled and what are the terms used for controlling engine power and what is the engine and all. This I am going to discuss in today's class. So this will be focusing totally on the engine. And engine is, if it is 2 engine, mostly on the wing. If it is a 1 engine, it may be here at the, if it is a propeller at the nose, or sometimes it is here at the fin. We have the 1 engine systems are there. If there are 3 engine, 2 will be here, 1 will be at the center on the fuselage, on top of the fuselage. So these different configurations of engines are here. This engine has to be controlled. This engine has to be monitored, and it should give a proper fuel supply and power supply as per the demand of the aircraft. So it is one of the very important component of any aircraft, and this gives a huge amount of energy, and this energy is achieved by the burning of the fuel. Mostly we burn the fuel in most of the aircraft is ATFK 50. For some small trainer aircraft where we have the piston engine, we use the avgas, and different types of fuels are used for different aircraft. And we have a specification also, which I have already discussed in my previous lectures. So today my topics and the CO mapping of today's lecture. The first topic is engine and its types. It is covering the CO4. Then we have fuel systems covering CO4. Engine cycles, CO4. Turbojet engine also CO4. Engine components also CO4. Thrust reversal, these are also CO4. So these are topics, their definitions and terminology I am going to discuss. However, I will go some more detail to explain the topics. So what is the engine? So that is the first question. Everybody will ask, define the engine. So engine has got different, like search engine. So engine, we can have a different things, but here I am talking about aero engines. any mechanical engine which normally we use. So a machine which moving parts that converts power into motion. So what is the engine? A machine with moving parts that converts power into motion. So any power, any type of power, maybe chemical power, like in our engines which I have shown here, we use some fuel. This fuel has to be burned inside the combustion chamber, and this burning of the fuel, a chemical energy will convert to the heat energy, and this heat energy will be utilized by the piston or by the turbine rotors, and this will be converted to the mechanical power. Next definition, we can see that a machine for converting any of various forms of energy into mechanical force and motion. So this another definition is given, that a machine for converting any of various forms of energy. So different types of energies, maybe chemical energy, thermal energy, or some solar energy, nuclear energy, any type of energy, if you convert to the mechanical force and motion, then we call it as an engine. Also, a mechanism or object that serves as an energy source. Black holes may be the engine for questions to a railroad locomotive. So these are some example. Here I have shown here, this is the piston engine. Piston engine, and this is the turbo engine. Mostly we use in our aircraft, so I have put here these two engines. Here we have the inlet valves, inlet, and this is the outlet or exhaust, and from here it is entering here, here, this air. Sometimes air and fuel mixture will enter here, it will go here, there is a piston here, this piston will be moving and it is sucking here, this air is sucked. After this reaching to the, it is a TDC, another is a BDC, bottom dead center. If it is reached to the bottom dead center, both valves, these valves will be closed, and then the compression will be there. So first is suction, second is the compression. After compression, the fuel will burn at the TDC. Third one is the expansion. In this valve, all the valves are cold. Fourth is the exhaust. So in that, this valve will open. This is the exhaust valve. This will open, and it will. This is here exhaust. This is the exhaust, and this is the inlet. So this valve will open, and this is the exhaust. Exhaust gases will go from here. So this is the basic principle of a piston engine. Here we have the turbo engine. In turbo engine also the same strokes are used. So first is the inlet here. Air is entered, your engine is rotated, it will go from the intake. These are the compressor stages. In this compressor, pressure is raised, compression is taking place up to here. From here, air will enter here in the combustion chamber. In this combustion chamber, a spark will be given, fuel will start burning, and the fuel jet with a high pressure. We are putting here fuel, and it is burning is taking place here, and some blue is the cooling, and it is mixing, and it is going to the turbine here. These are the turbine here. So this turbine will give the expansion, and here is the nozzle. In this nozzle, it will give high kinetic energy, and this will give the thrust. So in this way, these turbo engines are working. So I have given a definition also, and also I have given a working principle on the engine. Next, what are the 5 jet engine systems? So in jet engine, just now I have explained, there are 5 main jet engine system, and if you see here that we have the cooling system. All jet engines requires high temperature, so gas for a good efficiency. So we need to cool this thing. Next is the fuel system, engine starting system, ignition system, and the lubrication system. So just I will define one by one. Cooling system is the system which cools the engine, especially because the engine is very high temperature, and if this high temperature is maintained continuously, the chances of the failure of the material of the turbine, combustion chambers, even nozzles are likely to be happen. To avoid that, we have to cool the turbo engines. So one cooling system is required. In engine, we have the self-cooling. We don't have any water cooling and all, but we circulate the air in such a way that without the air which is not taking part in burning, that will go and mix with the gases which are taking part after ignition is taking place. So these, we can divide these things into primary cooling air, secondary cooling air, and tertiary cooling air. So just I will give some layout of this. This is here the combustion chamber, and here are the turbine. These are the turbines, and here is the compressor, and this is the combustion chamber. So this air is entering from here, and this goes to the combustion chamber. All air will not go, and here we will have some hole. So only some 25 to 30% of the air will take part in the burning. Remaining 70% will go from top, and after burning it will mix here. Before the turbine, this air is to be mixed with the burn gases, and temperature has to be cooled down, remaining the pressure high, and it will hit the turbine, and turbine will move. So nowadays we use the fan also here. Here we use the fan. This air will also enter, and it will join here to cool also and to give the additional thrust. So in this way we do the cooling of the engine. Next is the fuel system. As you know that we need to give the fuel to the system, to the engine, so that only we can get the power. So fuel systems, we have mainly gravity fuel system, another is the pressure fuel system. In gravity fuel system, the fuel is stored in a tank, and which is above the engine. So in a small aircraft for training and general aviation purpose, we can keep like this. There we don't use the pump. So it is very much essential that fuel tank should be above the above the engine of the aircraft. So, and another one, if most of the aircraft we have the pressure pump systems, in that a pump is fixed, and that will suck, and it will give a pressure. With the pressure, fuel will be supplied to the engine. In this type of aircraft, anywhere you can put the fuel tanks, below, above, or any place, and your fuel supply will be there. Another system is the engine starting system. In engine starting system, we should have one power source for initial cranking of the engine. It will be cranked. Then we will have the one torch igniter or the spark plug. Then we will have an injector pump. In the injector pump, a high pressurized fuel is supplied, and then the ignition by the spark plug is given. In this way, starting sequence, mostly the starting sequence goes for 60 seconds. In the 60-second starting sequence is completed. Next topic is ignition. For the ignition, we need a high voltage power supply to the engine, and like a spark plug or some torch igniters are there. Those number of igniters are there. So these igniters will give the current and a very high spark is given. Then we talk about the lubrication system. In this lubrication, mostly engine lubrication is very important. In this engine lubrication, we know that if the engine is very big and the length of this thing is quite sufficient, we need a number of bearings. These bearings are supporting the engine, and they are also in a very high temperature. So the bearings has to be lubricated by the lubricating oil. Normally we use the OX38 for engine bearing lubrication. This OX means oil miscellaneous. A oil miscellaneous, name is OX38, is stored in a tank. From there, it has got its own pressure pump, filters, pressure relief valve, and other equipments, return line, pressure line. We have also the sensors, pressure sensors, gauges to monitor the pressure and the temperature of this thing. These other systems are also there, and in this way, this lubrication system is formed. So I have discussed about this. Now I will go for the types of engines. We have three types of engines: internal combustion engine, that is called IC engine; external combustion engine, it is called EC engines; and the reaction engine. So here it is a piston type of engine, and it is called the internal combustion. Mostly what we use is piston engine, gas turbine engine, rocket engine. They all falls under the internal combustion engine. If you talk about external combustion engine, in this the fuel is burned outside of the engine, and from there this heat is transferred to other medium like steam. It is shown here. It is a external combustion engine. So in olden days, the coal was used to heat the steam, and this steam used to go to this piston and engine, and in this way it used to be give the power. So this steam locomotive was used, and this steam locomotive was is called the external combustion engine. Reaction engine, you can see in missiles, rocket launchers, or space vehicles. They are falling in the reaction engine. This reaction engine can go where the air is not available. So this reaction will give the action and it will move forward. So this is the types of engine which are used in our system. What is engine system? So that is the, I have to put a question mark here. So engine system means the engine, the emission control system, and the communication interface hardware and the messages between the engine system, electronic control units, and any other powertrain or vehicle control unit. So this you can see, when we talk about engine is only this much is the engine. If you see, this is the only engine. But once we talk about the engine system, it contains everything. So many things are here. Catalytic converters, your emission control systems, ignition coil, spark plug. This all falls under this system. So it is called engine system. So here we have engine system means the engine, the emission control system, and the communication interface, hardware and the messages between the engine system, electronic control unit, ECU, and any other powertrain or the vehicle control unit. So this you can see here, the fuel system is here. From here, fuel goes from here with the different things here. Here is the throttle valve. This is number 1. We have the number 2, we have airflow sensors. Number 3 is fuel pressure sensor here. Number 4 is crankshaft speed sensor. Here we have the speed sensors. Then we have the 5 here knock sensors here. Then we have the 6 here is temperature sensors. We have 7 here oxygen sensors. 8 we have the oxygen sensors again. A is a fuel injector here. A is a fuel injector and B is a ignition control. So this full makes one aircraft systems or engine system. So once we talk about engine system, it includes all sensors, all emission controls, power control, electronic control, everything is called the engine system. What is the engine fuel system? So now next question comes about the engine system, engine fuel system. So is there any other fuel system is there? Yeah, there is one is a aircraft fuel system and another is the engine fuel system. Okay, so just I will first discuss about one thing, then I will discuss about another. The fuel system is made up of the fuel tank, pump, filters and the injectors are the carburetor and is responsible for delivering fuel to the engine as needed. Okay, so this is the engine fuel controls fuel system. An aircraft fuel system allows the crew to pump, manage and deliver aviation fuel to the propulsion system and the auxiliary power unit of an aircraft. Fuel systems differ greatly due to different performance of the aircraft in which they are installed. A single engine piston aircraft has a simple fuel system. A tanker such as KC-135, in addition to managing its own fuel, can also provide fuel to other aircraft. So if we talk about the aircraft fuel system, and so aircraft fuel system consists of the tanks, their pumps which are fitted on the aircraft, and from there fuel is supplied to the engine. Till the time it is reaching to the engine, that whole system is called the aircraft fuel system. As and when the fuel is reaches to the engine, from there engine has got its own component like fuel pump, idling devices, governor, injectors, spark plug. These all are the part of the engine fuel system. So we should be very much clear about that. What is the aircraft fuel system and what is the engine fuel system? If you see about the maintenance part, in aircraft we are getting qualified as a aircraft maintenance and another is the engine maintenance. So the person who is qualified to maintain engine, they will look after the engine fuel system. And the person who is qualified or the technician who is qualified on the airframe, they will be looking after the aircraft fuel system. Both are not the same. Their working principle, their principle, methodology, management, everything is different. So we have to take care of that. Define stroke of IC engine. IC is inter-combustion engine. In the context of an internal combustion engine, the term stroke has the following related meaning. A phase of the engine cycle is the compression stroke, exhaust stroke, during which the piston travels from top to bottom or vice versa. The type of power cycle used by a piston engine, that is 2-stroke engine, 4-stroke engine. Stroke length, the distance traveled by the piston during the each cycle. The stroke length along with bore diameter determines the engine displacement. Okay, so what is the stroke? Okay, just I will explain here. This is the piston. This is the top dead center and this is the bottom dead center. These two are the extremes of this piston. So as and when it is moving from top dead to bottom, this is the one stroke. And first one, it is called the suction. Then next it goes from bottom to top. In this, both valve will be closed. This is the compression. Then here fire will take place. This is the spark plug. This is the inlet. This is the exhaust. So here this spark plug will burn the fuel and it will be compressed. So third stroke is the expansion. Expansion stroke. And after reaching BDC, exhaust valve will open and inlet valve will remain closed and the burnt gases will go out. So we have here 4-stroke system. So this each motion of the piston from top dead to the bottom set is called the stroke. And the length, this length from top dead to bottom set is called the stroke length. And multiplied by area of this piston is called the volume or displacement. Okay, so in this way your stroke is defined. Define aircraft engine. An aircraft engine, often referred to as an aero engine, is the power component of an aircraft propulsion system. Most aircraft engines are either piston engine or the gas turbine, although a few have been rocket powered, and in recent years many small UAV have used electric motor. So we have in different aircrafts we are using the different engines. Here we may use the piston engine, we may use the turbo engine, we may use the gas turbine engine, we may use the rocket, or we may use the electrical power engine. Mostly nowadays the solar power engines are also operated and they are generating the electric power. This electric power is rotating the propulsion and in this way we get the thrust. Now cycles of the engine, if you can discuss here, we have different cycles like Otto cycle, diesel cycle, dual cycle or semi-diesel cycle engine. So in Otto cycle, these types are used in the Otto cycle, and here it is shown here. This is the Otto cycle and this is the diesel cycle here. Diesel cycle is the engine working on diesel cycle is called the diesel cycle engine. Some engines follow the both dual cycle or the semi-diesel cycle. The engine that works on the both diesel as well as Otto cycle is called the dual cycle engine or the semi-diesel cycle. So what is the Otto cycle? Just now I have explained how it is working, and this same thing is here. So as you can see here, from 1 to 2 is a compression. So in this work is given. Here this constant volume Q in means energy is given. Spark is given here at the between 2 and the 3 at the constant volume. Then 3 to 4 is a expansion, isentropic expansion, and 4 to 1 is a constant volume heat rejection. So from here this heat is going out, here work is out, here work is in, here heat out. So this is the simple Otto cycle. The basic difference between two is this and this 2, 3 here and the 2, 3 here. In this heat addition in Otto cycle, heat is given at the constant volume. In this it is given as a constant pressure. So in diesel cycle everything is same except 2 and 3. That is the basic difference. So by this you can see this stroke is reduced comparing to this, because some part of the stroke here is used only for the burning. That is not in the case of Otto cycle. So this is the, and if you talk about the dual, so from here it will go like this, constant volume, and then it is go as a constant pressure. So it will become the dual. So that is the dual cycle. Now parts of jet engines. It is very much essential that we have to understand the parts of the jet engine. So we have the fan, we have the compressor, we have the combustor, we have the turbine, we have the mixer, and we have the nozzle. These are the fans. Nowadays, turbo fan engine, these fans are used ahead of the compressor. This is the compressor here. So before that, here, these fans are fitted. This gives the efficiency is increased, fuel burning, the fuel economy is improved, and power thrust is also increased. The size of the engine is reduced. So these are the purpose of the fan. If you talk about the compressor, we have the mainly two types of compressor. One we have the axial flow, another we have the centrifugal flow. Here I have shown here, this is the axial flow compressor. And if you talk about the centrifugal flow, it will be like this. So flow will go like this. So it is a centrifugal flow compressor. So next is the combustor. In this combustor, the air which is entering from the exiting from the compressor is the high temperature and the high pressure will enter in the combustor. In this combustor, fuel is injected. Fuel is injected here, and the spark is also given by the igniters spark. So this spark, it will give here, air is coming, fuel is coming, this high temperature and the high pressure air will enter and it will mix with the fuel and the burning will take place. So in the combustor, burning of the fuel is taking place. Then this will go to here in the turbine. The high temperature and the high pressure will be entering in the turbine, and their expansion of the gases will take place. This expansion will generate the work, and this work will be transferred to the shaft, and this shaft will be rotating the propeller for the turboprop engine. And if you talk about the turbojet, the stages will be very less. Turbines are only used to rotate the compression, and remaining high energy gases will go to the nozzle, and in the nozzle this cooling air will be mixing here and the temperature will be reduced, and this will go to the nozzle, and here expansion of the gases will take place and thrust will be generated. Action and the reaction here will take place. So here if it is a turboprop engine, you have more number of turbines, because all the heat which is generated on the combustor should be utilized by the turbine, and very limited amount of gas will go to the exit. But in a turbojet engine, the turbines are only used to rotate the compressor, not for the other purpose. So this is the basic difference, and you can identify by the number of the stages. If the number of stages are more than 3, then you can understand it is a turboprop engine. And if the turbines are less than 3, then it is a turbojet engine, because only few percentage of the gases are utilized for this purpose. So this I have completed the parts. Now I will go to the next question. It is define jet engine and its principle. So a jet engine is an engine that discharges a fast moving jet of the fluid to generate thrust in accordance with Newton's third law. So in this, what happened? This is the nozzle here. So here it is a combustion chamber, and it is high temperature and high pressure air is entering, and it is going in the nozzle. A very high velocity will be exiting. The aircraft will move in this direction. So that is the action and the reaction. Any jet engine is working under this principle. So the working principle, jet engines are also called the gas turbines, The engine suck air. So here is air sucked. The engine sucks air in at the front with a fan. A compressor raises the pressure of the air. The compressed air is then sprayed with fuel and electric spark light the mixture. The burning gases expands and blast out through the nozzle. At the back of the engine, as the jet of the gas shoots backward, the engine and the aircrafts are thrust forward. So these are the, here we have the water jets, we have the motor jets, turbofans, rocket jets, and the ramjets. These are the few types of the jets. Define air intake. So what is the air intake? If you see about the piston engine, here I have shown here, these are the inlets. From here the intake. From here air is entering, with the filtered air is entering. If you see your turbo engine, this is here inlet or intake. This part is where initially air is entering. It is called the intake. So an air intake is an opening through which air enters an engine or the system, usually for combustion or cooling. Air is drawn into the engine through the air intake. The airflow first passes through the air intake when approaching the engine. And air intake is an opening through which air enters an engine or the system, usually for combustion or cooling. Now I will talk about the compressor. And what is the compressor? It is used for the compressing the air, which is entering. Air is a nearly atmospheric, but we need a high pressure to enter in the combustion chamber for burning of the fuel in a good way, and its efficiency of the aircraft has to increase. So the compressor is the first component in the jet engine core. The compressor is made up of fans with many blades and attached to a shaft. The compressor squeezes the air that enters into progressively smaller areas, resulting in an increase in the air pressure. This results in an increase in the energy potential of the air. The squeezed air is forced into the combustion chamber. So here, if you see here, the area is decreasing here. This is the compressor, and if you see here, the area of this first one and then the last one is increasing, and this much volume is decreased here. So the pressure is increased. So it is a pressure and area relations. As the area is decreasing, the pressure is increasing. So that is the compressors. Next is, what is the turbine? The turbine, it is the high energy airflow coming out of the combustor, goes into the turbine, causing the turbine blades to rotate. The turbines are linked by a shaft to turn the blades in the compressor and to spin the intake fan and the front. This rotation takes some energy from the high energy flow that is used to drive the fan and the compressor. The gases produced in the combustion chambers move through the turbine and spin its blade. So this you can see here, the turbine's blades are here, here. They are shown here, and these turbine blades are used to convert chemical energy or the heat energy into the mechanical work, and they are rotated, and this rotation is goes with the shaft, and in the shaft we have the compressor, we have the propeller, we have other rotating part. Also this is used to give some additional kinetic energy. This kinetic energy will go to the nozzle and a high velocity gases will flow from there. So the purpose of this thing is also to increase the kinetic energy, and this kinetic energy when entered to the nozzle, this will produce a high thrust for the aircraft. Define the turbo pump. Turbo pumps are centrifugal pumps which are spun by gas turbines and are used to raise the propellant pressure above the pressure in the combustion chamber so that it can be injected and burnt. Turbopumps are very commonly used with rockets, but ramjets and the turbojets also have been known to use them. So mostly these type of turbopumps are used for the rockets, for the space vehicle, but sometimes in our jet engines are also these things are used. Define the thrust reversal. You know that nowadays engines are very high speed. During the landing we want a reduced runway length. Even sometimes we want the vertical takeoff and the landing and the short takeoff and landing. That time we want some devices which can reduce the or inverse or reverse the thrust. Those components are called the thrust reversal. So thrust reversal also called the reverse thrust is the temporary diversion of the aircraft engine's exhaust or changing of propeller pitch so that the thrust produced is directed forward rather than aft. This acts against the forward travel of the aircraft, providing deceleration. So this you can see in this diagram that these are the thrust reversals. Thrust reversals. So what happened? As and when we want to reduce the speed, the direction of the thrust is reversed. In place of going this direction, if you make like this, reverse, it will try to stop. And if you make the 90-degree down, it start hovering. So this is the purpose of the thrust reversal which are used in the aircraft. Here also it is shown here. These are the thrust reversal. Next is the fuel system. Apart from providing fuel to the engine, the fuel system is also used to control propeller speeds, compressor airflow and cool lubrication oil. Fuel is usually introduced by an atomized spray, the amount of which is controlled automatically depending on the rate flow. It also increases the energy extracted by the turbine which drives the compressor even faster, and so there is an increase in the air flowing into the engine as well. These are the references which I have taken from the Moyer and the Seabridge aircraft systems, mechanical, electrical and avionics system. Then Moyer and the Seabridge design and development of aircraft systems and introduction. Any questions you are welcome to ask. This is my email, ydwivedhi@gmail.com. Thank you very much for joining my class. Be tuned for my next lecture and please like and subscribe my channel. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.